Hello friends, welcome to this session. In this session we are going to study about microprocessors. First of all, we'll have a look at history. In 1947, invention of transistors uh, took place, and in 1959 the integrated circuits were invented. Then in 1965, birth of Moore's law took place. Moore was the co-founder of Intel Corporation, and he stated that the transistors per plate would double every 18 months. And later on, this statement given by the Moore was called as Moore's law. And later on in 1971, first microprocessor was invented by the Intel Corporation, and it was named as Intel 4004. And in 76, the first microcontroller was invented. A microprocessor is basically a multi-purpose device. Multi-purpose means you can perform multiple tasks with a microprocessor. It is programmable. Programmable means you can program it according to your needs. Then it is a clock driven. Clock driven means it depends on the control signals, means which statement is to be executed at what time. And it is a register based electronic device, means it contains registers, and it accepts binary data as input. Binary data means data in the form of bits, that is 0 and 1, and processes data according to the instructions given to it and provides results as output. The binary instructions are given abbreviated names called mnemonics. This is an important point according to the exams point of view. That is the mnemonics. Mnemonics are the binary instructions, and these mnemonics forms the assembly language for a microprocessor. Now we have a difference between microcontroller and microprocessor. Microcontroller is a single chip, whereas microprocessor is a CPU. Microprocessor consists memory and input-output ports. In microprocessor, memory and input-output ports are to be connected externally. CPU is standalone. RAM, ROM, input-output, timer are separate in the case of microcontroller. And in case of microprocessor, CPU, RAM, ROM, and input, output, and timer are on a single chip. In microcontrollers are versatile and general purpose, and microprocessor is a specific purpose, that is control oriented. Microcontroller consumes high power, whereas microprocessor consumes low power. Now we have a table of evolution for microprocessors. In 1971, the first microprocessor was invented by the Intel, and it was named as Intel 4004. And it was having 10 address buses and 4 data buses. In 1974, Intel 8080 was invented, and it was having 16 bits of address buses and 8 data buses. In 1976, 8085A was invented. Generally it is named as 8085, and it was having 16 address buses and 8 data buses. In 1978, 8086 was invented, and it was having 20 address buses and 16 data buses. And then in 1985, 8038.6 was invented, and it was having 32 address buses and 32 data buses. After that, in 1997, Pentium 2 was invented, and it is having 36 data buses and 36 address buses and 64 data buses. Next we have bus architecture of microprocessor based system. The bus architecture consists of microprocessor, input output ports, and the memory. Memory contains read write and ROM memory, and these components are organized on a common communication path, which is called as system bus or bus. Basically the system buses are the wires which connects these components of the system. The entire group is called the microprocessor system. Microprocessor is again divided into three segments. First is ALU. ALU is an acronym for arithmetic and logical unit. It performs arithmetic and logical operations. Arithmetic operations like addition and subtraction, and the logical operations like AND, OR, and extended OR. And the second segment of the microprocessor is register array. Register array is a group of registers generally called as the B, C, D, E, H, and L. These registers stores temporary data during execution of the program. And the third segment of microprocessor is control unit. Control unit provides timing and control signal to the operations. It also controls flow of data between microprocessor, memory, and peripheral devices. Peripheral devices are basically the input-output devices. Next component is memory. It stores binary information as instructions and data, and provides that info to the microprocessor. Then microprocessor reads data and instructions and performs arithmetic and logical operations according to the instructions, and the results are transferred to output devices, or it is also stored in memory for the further use. Memory is divided into two parts, that is read-only memory and random access memory. Random access memory is also known as the read-write memory. Read-only memory is used to store the programs that do not need to be altered, and the read-write memory, also known as the user memory, and it is used to store user programs that can easily be read and altered. Then the next component is the input and output. Input devices transfer binary information from outside world to the microprocessor, and output devices transfer data from microprocessor to the outside world. Then we have system buses, as I have already explained that it is a communication path between microprocessor and peripheral devices. You can say it is a group of wires to carry the bits. Microprocessor communicates with one peripheral at a time. This is an important point from the examination point of view, that is microprocessor communicates with one peripheral at a time, and this timing is provided by the control unit of the microprocessor. Now we have some important points like scale of integration. Scale of integration is of many types, like small scale integration, which is SSI, and medium scale integration, that is MSI, then large scale integration, which is LSI, and then comes out to be very large scale integration, that is VLSI. In SSI there are less than 10 gates on a plate, and in MSI there are between 10 to 1000 gates on a single plate, and in LSI there are greater than 1000 gates, and in very large scale integration there are greater than 1 lakh gates on a single chip. And you must be known that byte is of 8 bits, and there is a term nibble which is of 4 bytes, And then we have ASCII, which is an acronym for American Standard Code for Information Interchange. It is of 7-bit alphanumeric code and with 128 combinations. Then we have extended ASCII, which is of 8-bit code and with 256 combinations. Next we have bus structure of 8085. In the bus structure, in microprocessor, we have 16 address buses, which are from A0 to A15. They are unidirectional and carries 16-bit address. And there are 8 data buses which are from D0 to D7. They are bidirectional and passes 8-bit data. And the control buses provide the control and timing signals, and they have no link to address and data buses. They generate pulse whenever microprocessor fetches any data, and according to this pulse, input read-write operation is performed. Now we will study about 8085 registers. First register is program counter. It is a 16-bit register. It contains the address or the location of the instruction being executed at the current time, and as each instruction gets fetched, the program counter increases its stored value by 1. Then we have registers. These registers stores temporary data, and these are named as B, C, D, E, H and L. These are 8 registered and stores the temporary data. Then we have accumulator. It performs arithmetic and logical operations. And then we have flag registers. It sets and resets the flags. Then we have stack pointer, which shows the data at that address. Now we will study about flag registers. Flag registers is a group of 5 flip-flops used to know the status of various operations done. And you can see in the diagram, these are S, Z, A, C, which is auxiliary carry, and P, C, Y, the carry flag. And the flags which are the registers which are marked as cross are the don't care flip-flops. First we have the sign flag. It is also called as the negative flag, and it is set when result of the operation is negative. Then we have zero flag, which is set when result of an operation is 0. Then we have auxiliary flag. It is also known as the adjust flag, and it is set when there is a carry out of the lower nibble or lower 4 bits of the operation. Then we have carry flag, and it is set when there is a carry generated by an operation. Then we have parity flag, and this parity flag is also known as the odd or even flag, and it is set when results contain even number of ones. 8085 uses these flags in decision making process. And with this we came to the end of this session. Thanks for watching.